All right, in this video I'm going to be working some related rates examples. And let's see, what are we going to start with? We're going to start with a spherical snowball is melting in such a way that it maintains its shape. The snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. At what rate in centimeters per hour is the radius decreasing at the instant when the radius is 10 centimeters? All right, so decreasing in volume 8 per hour. So that means that dv dt equals -8. What is dr dt when r equals 10? So we know they told us in the statement of the question that v is 4/3 pi r to the third. Okay. So dv dt, if I just take the derivative of the whole equation with respect to time, I'll power be 4 pi r squared times the derivative of r with respect to t for the chain rule. Then I'm going to say, well, I've pretty much got everything. I've got this is -8. I've got this is 10. I should be able to solve for that. So -8 equals 4 times pi times 100. And that would mean to me that dr dt at the time where r was 10 would be equal to -8 divided by 400 pi. I mean, like, we could probably reduce that to -1/50 pi if we wanted, but no, you don't need to. All right. So let's move that up one. The volume of a sphere is decreasing at a rate of 12 inches, cubic inches per second. Okay, so yes, so this one steps up the difficulty a little bit. I was like, I shouldn't have put the same question on there twice. Okay, so dv dt is going to be 4 pi r squared dr dt. And the volume is decreasing at 12, so that's -12 equals 4 pi. We don't know r quite yet, but I think we'll be able to find it. And we want to figure out dr dt. So really, I think our job now is to figure out what is r that makes surface area 36 pi. Okay, so s equals 4 pi r squared. They're saying s equals 36 pi. I think that means that r squared has to be 9, meaning r is 3 or -3, but I'm not interested in when r is -3. I don't even know what that means. So, and moreover, I'm actually not interested in r. I want r squared. So that'll be 9. And dr dt is the thing I'm hoping to find. And so that means that dr dt will be, I'm going to take -12 and divide it by 36 pi. So -1/35. All right. Cube with edges of length x centimeters has volume x cubed, so cubic centimeters. Volume increasing at a constant rate of 40. Okay, so dv dt is 40. The instant when x is 2, what is the rate of change of x with respect to time? Well, I think this should be pretty all right, because if v equals x to the 3, we can take the derivative with respect to time pretty easily. That'll be 3x squared times the derivative of x with respect to time. So dv dt is 3 times 4 times dx dt. So 40 is 12 dx dt. And I believe that that will mean that dx dt is 40 divided by 12, which, I mean, I'm sure you could reduce 20/6, 10/3. What's the next one? Whoops. Cup has the shape of a right circular cone. The height of the cup is 12 centimeters and the radius of the opening is 3. Now remember, with the cones, you got to be a little more careful because of, kind of the similarity relationship as the water drains or fills up. Okay, so the height is 12, radius is 3, and water is poured in at 2 cubic centimeters per second. Okay, so dV dt is 2. What is the rate at which the water level is rising? I'm going to call that h. When h equals 5. Okay. So what I'm going to need to do, I see that v is 1/3 pi radius squared multiplied by height, but I'm going to be looking for dH dt. So I need to substitute on r. I need to get rid of my r. But I know that, at any given time, this triangle here is similar to this whole triangle, meaning that r over h is always equal to 3 over 12. Meaning that r is 1/4 of h. So if I go over here, so that's 1/3 pi h divided by 4 squared multiplied by h. I think it would be smart to actually square it before taking the derivative. So that'll be h squared, h to the 3rd. I'll be divided by 16. So I'll have pi over 48 h to the 3. And then that means the derivative of volume with respect to time is going to be 3 pi over 48. So that'll be pi over 16, h to the 2 times dH dt. And I think I've got everything I need here, right? Okay, yeah, dV dt is 2, h is 5. So 2 equals 25 pi over 16 dH dt, which I think means that dH dt is going to equal 32 divided by 25 pi. All right, now we've got a region bounded by 2 concentric circles. Okay, so yeah, simultaneously the outside circle is getting bigger and the inside circle is getting smaller, so the rate of change in square inches per second of the shaded region's area should be positive. Okay, just throw that out there. At the instant when large r is 4 and small r is 3. Well, the area of the shaded region is pi r squared minus pi r squared. And so I can take the derivative of area with respect to time. That'll be 2 pi large r dr dt for the large r minus 2 pi r dr dt, r being small r. And I think I've got everything I need, right? They said large r is 4, so that's 8 pi times that is 2 minus 2 pi, small one is 3, so that'll be 6 pi times -1. Notice this is 16 pi plus 6 more pi is 22 pi. Kind of makes sense, right? We said that the area needed to be getting bigger. So its derivative with respect to time would be positive. All right. Oh yeah, I threw this one on here. I don't know if this is exactly related rate, but it is an implicit differentiation with respect to time, and they give you a relationship between 2 variables. So, I mean, categorically it is pretty much related rates. So p squared equals 20 minus c to the 3rd power. Okay, I can work with that because I'm just going to take the derivative with respect to time. So that's 2p dp dt equals 3 times this thing, leave it the same, take it to the 2 power, take the derivative of the inside, it's going to be you could say -1 times dc dt, or you could just say the derivative of the inside was negative dc dt, however you're looking at it. And, well, then I've got all the pieces, right? I've got at the moment when dp dt is 41, so 2p times 41 is going to be, c is 15, so 3 times 5 squared is 25, times -1, and dc dt is what I'm hoping to find. And you'll be like, wait a second, I've got two variables here. How am I supposed to find that? And remember, if they give you c, there's a relationship between p and c, and so you should probably be able to find it. And then they're going to say p is a positive variable. That's the fine print. So I'm going to need to go back over here and figure out what is p. So p squared equals 20 minus c is 15 to the third power. 5 to the third is 5, 25, 125. So I think p is going to be the square root of 125, which I guess that's fine. Okay. I'm trying to remember where this problem came from. So 82 square root of 125 divided by -75, that's what dc dt is. All right. We've got an isosceles right triangle, which is half a square. Right? I'm calling it S. I might actually just call it X instead of S. At the instant when X equals the square root of 32, the area of the triangle is increasing by 12. What is the rate of change of the length of the hypotenuse of the triangle? Okay, we can deal with that. I think we're going to need, oh, that's a good one. I haven't seen this one yet. All right, so a equals 1/2 x squared. dA dt is going to be 2 times half is 1, x times dx dt. Okay. And, all right, yeah. Nope, I'm almost running off the screen. But yeah, I've got 12 equals x is square root of 32 times x prime. Okay, so 12 equals square root of 32 times dx dt. Meaning dx dt is, this should be, yeah, 16 times 2. Okay, so I don't know if that'll be useful, but I'm going to call that 4 root 2. Yeah, if I take 12 and I divide it by 4 root 2, that's going to be 3 over root 2. That might be useful. And yeah, okay, so I've got x prime, but they want h prime. So I need a relationship between h and x. So, I mean, maybe you know from geometry that h is equal to x multiplied by the square root of 2. But maybe you don't. Maybe you need to see that for yourself. You say h squared equals x squared plus x squared. And you take the derivative of this with respect to time. 2h dh dt. 2h dh dt equals 4x dx dt. And now I've got all of this. That's interesting. Oh, okay. That's very interesting. Like, this would have been much easier to take the derivative of, and like h prime is going to be 3 over square root of 2 times square root of 2, meaning that it's going to be 3. But I'll just show you the long way, I guess. If you had to start off with the Pythagorean theorem, this is where you would be, and so I wouldn't want anybody to be lost. So 2h, do we even know what h is? Oh yeah, it's going to be 32, square root of 32 times square root of 2 is going to be, square root of 64 is 8. And 16 dh dt equals 4 times the square root of 32 is 4 root 2 times dx dt is 3 over square root of 2, so I'm just going to do that. 16 dh dt is 3. How do you want it? Alright, the last one, I'm going to have to adjust the camera to get this whole problem in. Alright, for 0 to 6 seconds, a screensaver on a computer screen shows two circles that start as dots and expand outward. At the instant that the first circle has a radius of 9 centimeters, the radius is increasing. Okay, so the derivative of radius 1 with respect to time when radius 1 equals 9 is going to be positive 3 divided by 2. Find the area at which the area of that circle is changing. Okay, yeah. So a equals pi r squared, dA dt is 2 pi r dr dt. So I've got r and dr dt, so I should be able to do this without too much trouble. 2 times pi times r is 9 times dr dt was 3/2. This is a free response question. You can just stop there, right? Oh, but they did say indicate units of measure. Let's think, what is a measured in? It's going to be measured in square centimeters. What is t measured in? It's measured in seconds. So it's going to be square centimeters per second. And then I'm going to, no, I think that's good, right? Yeah. The first circle has radius modeled by w of t. When is the radius increasing 3 centimeters per second? Well, minus 12 e to the negative 0.5 t. So, I mean, they want to know when the w prime equals 3. So w prime of t is equal to 0. Okay, so it's going to end up being plus 6 e to the negative 0.5 t after the chain rule, multiplying the negative 12 by the negative half. All right, so w prime of t equals 3. I'll just set that equal to 3. I'm going to divide by 2. So e to the negative 0.5 t equals, solve for this by taking the log of both sides. And then I'll just divide by negative 0.5. Again, it's free response. That's a perfectly safe place to stop. All right, and then part C, a model for the radius of the second circle is given by the function f for 0 to 6, where f is measured in centimeters. How many centimeters does the radius of the second circle increase from time t equals 0 to t equals 3? Well, what would be the difference? So f is the radius. So what I need is, I'm looking for a value of f of 3 minus f of 0. And I could probably get that, if I have f prime and I want the difference in two f values, I can use an integral, right? I can use the fundamental theorem of calculus. So that'll be the integral from 0 to 3 of f prime of t dt. They told us that was t squared minus 4t plus 4. I mean, okay, you can do this the old-fashioned way if you want. I'm going to just write this again. That's t minus 2 squared. So that'll be 1/3 of t minus 2 to the third power. You can check, make sure there's no chain rule implications. So that'll be 1/3 of 1 minus, okay, that's actually going to require more arithmetic because of the 0 minus 2, so I'm going to need a second scrap of paper. Yeah, it's the last problem anyway, who cares? So 1/3 of, I'll factor out the 1/3. 3 minus 2 is 1 to the third minus negative 2 to the third If you wanted to stop there, that's fine. If you wanted to say that was negative 8 plus 1 is going to end up being 9, divided by 3 is equal to 3. However you want it. Okay. And that's all for this particular set of related rates example problems.